In this section, ladies and gentlemen, we are going to be talking about Mars. Actually, I'm going to do something kind of goofy. I'm going to go back to a red pen because Mars is very often referred to as, of course, the red planet. This is an absolutely stunning picture of Mars because of the fact that you see things that are so familiar. They look Earth-like. This is an ice cap on one of the poles. I believe this is the southern pole of Mars. And if you take a wild guess, what's this kind of blue on the outside edge? That's the Martian atmosphere. You can actually see the envelope of air that surrounds planet Mars. So it is, in many ways, more familiar to us than any other planet out there. It is the closest thing we have to planet Earth. It is about 1.5 astronomical units away from the sun. And because of the fact that Mars does appear red when you see it, and if you spot it in the night sky, it looks kind of red. They named it for the god of war. And of course, the god of war has to do with blood, which is not terribly polite or fun to think about, but that's why it got the name. Mars is relatively small. It is about less than half the size of the Earth, and here is the little symbol that you're going to see periodically for Mars. Now, the size of Mars and some of the rocky planets compared to Earth, as we mentioned last time, Venus is kind of our sister planet, very similar to us in size. Mars is about 1/3 the size of the Earth. Mercury is smaller, and then, of course, Pluto, the dwarf planet, is smaller still. Mars is the first planet besides Earth that has moons as you're going outward from the sun in the solar system. These are the two moons of Mars. They are named Phobos and Deimos, and they're named Phobos and Deimos because of the fact in ancient mythology there was Mars the war god, and he had two war horses that drew his chariot into battle, and those were named Phobos and Deimos. And there are different translations. The one that I'm familiar with is they're called fear and panic because, of course, that is part of war. Martian moons do not look like our moon. As you recall, the Earth and the moon had a collision very long ago, which made them both molten, and in their molten state, they reconstructed themselves back into a very spherical shape. Well, if you look at Phobos and Deimos, you can tell these are not round by any stretch of the imagination. They are very kind of wacky shaped, sort of oblong. They're very cratered, and because of their odd shapes, we're pretty sure that Phobos and Deimos were not part of the creation of Mars. These were captured asteroids. Mars was just doing its thing in the solar system. Some small little rocks came floating by, and they got trapped by Martian gravity, and that's how the Martians got their moons. Martian gravity, because of the fact that Mars is about 1/3 the size of the Earth, Martian gravity is about 1/3 the size of the Earth. So what that means is if you weighed 100 pounds on Earth, you would weigh somewhere in the vicinity of 33 pounds on Mars. And we're going to periodically talk about the Matt Damon movie, The Martian, because it was not a bad movie. They did a decent job of recreating some of the science. There were a few limitations, and there were a few things that they took some liberties with in order to tell a good story. But there's a whole bunch of decent science that's out there. So if you're looking for something kind of fun to watch that is not totally devoid of science, I highly recommend The Martian. The reason I have the picture here is I noticed when I watched that movie that Matt Damon was not kind of jumping around the planet like he weighed 1/3, and I'm sure they made an executive decision early in the making of that movie that that might just plain look silly, so they didn't do that. Mars is, as I said, red, and it looks red from way over here on planet Earth, but we've sent so many probes to Mars, we have good close-up pictures of it. This is actually a picture of the Martian surface, and the rocks and things on Mars have not just red like Christmas red, they are rusty red, like an old pickup truck, like a rusty old nail, something like that. We think that that is humongous evidence that in the past there was oxygen and water, and a decent amount of both, in the Martian environment, because you have to have iron and oxygen, and the whole process is sped up with the addition of water in order to make rust. So these are huge indicators of Martians' past. Aside from that, like all of the terrestrial planets, the planet Mars is mostly made of aluminum, silica. Silica basically is a silicon and oxygen kind of rock, and that's the same kind of rock that makes up the Earth. So similar, but not the same composition as our planet. The interior of Mars has a solid iron core. Now, if you remember from planet Earth, on planet Earth we have a solid core, and then we have a liquid core, and it's the swirly motion of that liquid core that gives us our magnetic field. Well, because Mars is only about 1/3 the size of the Earth, we believe that it cooled and that this core solidified a long, long, long time ago. It is easy to cool a small thing than it is to cool a bigger thing like the Earth. Now, because of this cooled magnetic field, there is still iron rock that's down there, but it's the motion of the fluid in our core that gives us our good, strong magnetic field. There is still somewhat of a magnetic field caused by the core of Mars, but it is weaker because of the fact that it lacks the motion. There's no swirly motion to make that occur. So what's a big deal about this magnetic field? If you have a magnetic field around a planet like Mars, it is going to protect the atmosphere, protect that atmosphere from being blown away by the solar wind, and it is going to protect things that are on the planet, like the little early stages of life. So one of the things that a lot of probes that we're sending to Mars is looking for, we are looking for life on Mars. At the time I'm taping this, no definitive proof that there has ever been life on Mars has been detected. But we keep looking because Mars is certainly the place most like Earth that we are going to probably find life, at least at this moment in time as we're thinking about it. Now, the atmosphere that is left on Mars, and there is some, is about 1/10 the atmospheric pressure on Earth. So that's enough of an atmosphere so that they actually have weather. This is a picture from a Martian probe looking at the Martian atmosphere. As you can see, the sun is much smaller in the sky because it's 1/2 astronomical units, 1.5 AUs further away, from the sun, when we are only 1 AU away. Mars has a pinkish or yellowy brown color to its atmosphere, due to a great extent because of the fact that it is mostly carbon dioxide, little nitrogen, little argon. Earth, of course, is mostly oxygen and nitrogen. So a very different chemical composition is giving us very different colors. Temperatures on Mars. If you have some sort of an atmosphere, and Mars definitely has this envelope of air around it, that atmosphere helps equalize temperatures, and it helps spread the heat around. Now, what that means is near the equator, you can get temperatures that would be downright pleasant, like 68 degrees Fahrenheit. The problem is because the atmosphere is so incredibly thin, it's not going to hold the heat. And because it doesn't hold the heat at night, it can get down to minus 243 Fahrenheit, which is crazy nutty cold. And the actual average daily temperature on Mars is minus 60 degrees Fahrenheit. So yeah, you're not running around in your swimsuit on Mars. I mentioned this before, but these are some nice pictures to kind of illustrate that fact. Why doesn't Mars have more of an atmosphere? Well, the solar wind. If you have a strong magnetic field like Earth does, the solar wind comes along and it gets deflected around that tiny, very precious atmosphere around the planet. Because Mars has a very thin and weak magnetic field, it's just not strong enough to protect a lot of the solar wind from blasting away its atmosphere. A day on Mars is about 24 and a half Earth hours long. So it's really similar to us in length of day. When you talk about a solar day on another planet, it's referred to as a sol. And one solar day on Mars is real close to ours. A Martian year is just about 2 Earth years. So if you are 20 years old at this time, you are only 10 on Mars, or something darn close to that. The other thing that's interesting about Mars is its orbit is a lot more elliptical than Earth's. And when Mars is further away, it's going to have slightly different heating and cooling than closer. That plus tilt issues does create seasons on Mars. One of the things that occurs with the different seasons on Mars is it gets polar ice caps. There are north and south polar ice caps that happen in the Martian winter. This is a lovely but old collection of pictures, but it's a really nice illustration. This is October 1996, and this is a winter photo of Mars. And look at all that ice. That is actually ice. We believe a lot of it is water ice. We believe a lot of it is solid carbon dioxide ice because the atmosphere on Mars is mostly carbon dioxide. When it is summer on Mars, look at the size of the polar ice caps, tremendously smaller, and we have exactly the same effect or situation here on planet Earth. The seasons on Mars are going to change because of differences in tilt and differences in distance from the sun. It also has a tendency to have storms. It's the only other, well, it's not the only other planet that has storms, but its storms are really similar to what we're going to see on Earth. They actually have tornadoes that are referred to as dust devils in their atmosphere. These can be 5 miles high. Okay, 5 miles is about 25,000 feet. This is up altitudes at which on planet Earth, these are the altitudes where jets fly if you're going across the United States on a jumbo jet. So these are really tall tornadoes. On planet Earth, a tornado might only be about 1,000 feet, and this is 25,000 feet. So really, really nutty big. Dust storms sometimes can cover most of the surface of Mars. These are 2 pictures from Hubble. This is 2001 in June, and then September that same year. And you can see when Mars was quite clear, not a lot of dust everywhere, and when Mars got really covered in dust due to a dust storm. One of the challenges we have is the probes that we send to another planet often are solar powered. So this was the Opportunity probe that was sent to Mars. And one of the challenges that occurred is that slowly over time, it just plain got dusty. Dust from the atmosphere, little poofs of dust, caused the solar panels to be covered. The challenge was that limits its power. And if the power gets limited enough, the probe ends up being shut down. It shuts itself down because it just runs out of battery and runs out of juice. Well, the nice thing about these periodic dust storms is that once in a while, they just clean stuff away. And that can be very handy and very, very useful. Okay, we are going to stop right there. Mars is a big topic, and we're going to come back and continue this in Mars Part 2. So we will see you then.